Hello friends, welcome to my YouTube channel Learning Videos. So in this video we are going to see the usage of multisim and how we can realize the game. So here you can see two inputs A and B, and this is the expression for sum and this is the column for carry. 0 plus 0, the value is 0, carry is also 0. When we add 0 with 1, the sum is 1, carry generated is 0. When we add 1 with 0, the sum is 1, carry generated is 0. Now, when we add 1 with 1, the sum is 0 and the carry generated is 1. So, to define the sum using expression, we are using k-map. So, here you can see two variable k-map where a can take values 0 and 1, whereas b can take values 0 and 1. So, now we'll see when a is 0, b is 0, what is the value? When a is 0, b is 0, some value is 0. When a is 0, b is 1, some value is 1. When a is 1, b is 0, some value is also 1. When a is 1, b is also 1, some value is 0. So now, as the Karnaugh map says, we need to make group of 2 or 4. So here we cannot make group in this diagonal manner. So we can make in horizontal manner or vertical manner. So this will become one group and this will turn out to be another group. So if I want to mark, so this will be one group and this will be the another group. Okay. So now for this, what is the value? For this value is A bar B, and for this value is AB bar. Okay. So some expression we got as A bar B plus AB bar. Okay. A bar B plus AB bar, which is nothing but A plus B, that is A XOR B. So in the same manner, we are going to check for carry. So now here in the carry, you can see we'll generate carry only when A and B both are 1. So you can see A and B both are 1. So carry is generated. So this we are going to make it as a group, and the expression for this will be A, B. Okay, you can see the expression for this will be A, B. So now when we plot this, so the logic gate with using logic gate, so it will be A XOR B. So we are giving it to an XOR gate. Next, we are giving it to an AND gate. That is A dot B. That is AND. So C is carry and this one is the sum expression. So now we have realized the same thing using gate. So as we know that we are going to do this in two ways. First, we'll apply the signal. That is using function generator, we are going to apply. So from this, so this is where this will be my playground. So here, if you see, if you move to the right hand side corner, so here, if you see, so we have a function generator. Okay, this is called as function generator, second one. So I need two function generator. Okay, so this will be my input A, this will be my input B. So now, after this, I want one XOR gate. So I'll go to place, components. Here I'll go for TTL. And now I need to select XOR. So you can see over here in 74 ALS family. So we have one gate called as 74 ALS 86M. So which is what you can see here. It is 2 input XOR gate. Okay, so I'm going to use it. Click on A. So this is 2 input XOR gate. I'll cancel it. Okay, what is my expression for sum? It is A XOR B. So XOR gate is there. So I just need to pass A and B. Okay. So for this to check the output, I want oscilloscope. That is 4-channel oscilloscope. I'll click this and I'll drag and keep it over here. Okay. So next, I need to do this calculation for sum also. So sum it is, we can see from this, it is A dot B. That is A and B. So we'll go to the design once again. So now let us, so here in this menu, you can see a TTL. From this also you can place the logic gates. So I'm going to click this. So I want AND gate, search for AND gate. So on the first one, we are going to check. This is NAND gate. This is this is NOR gate. So this is NOT gate. This is a buffer. Yeah. So we got an AND gate. So here you can see quad 2 input AND gate. So I'll press OK. And here I'll click on A. Yes. So I got both the gates. So now what I'll do is I'll connect this. I'm considered as A with first input, B with second input. I'll connect the output. To check the output, I'll connect it to an oscilloscope. Next, AND. So what is an expression for carry? It is A and B. So again, I'll go to the design. So I need to connect this to A. This is my A. I need to connect this to B. So this is my this is my B. So I have connected. So to observe the output, I'll be connecting this to B. Okay. So now we need to do one more thing. We need to use this, make this negative to ground. So again, go to place, component, click on sources, click on power source. First one power source, then we have ground. Click on this, click on OK. So now I'll place this ground over here. I'll close this. Next, attach the negative terminal to ground. Negative terminal to ground. So to observe the input, I'll attach C to A, C to A, and D to B. Okay. So now, so I need to configure the function generator. You can see over here, function generator is producing the sine wave. So I want it to produce a square wave, and frequency should be 100 hertz. Close it, then go for input B. Keep it on a square wave. Make the frequency as 150 hertz. Close it. Now once again, I'll run this. Now I'll check the output. So this is the output. So since it's a black screen, I'm going to reverse it. Yes, you can see it's reverse. So now here you can observe where my mouse is hovering. This is channel A. Okay, channel A. So I'll increase the divisions so that it is visible for me. So I have kept 20 volts per division. So likewise, do for other also. So now you can see we are in the channel D. I'll do for 20 volts per division. Next, channel C, 20 volt. Next, channel D. Yes, next channel B, 20 volts per division. So now I'll separate this. As you know that A is my output for sum and B is my output for carry. So now I'll place A at the top. So by moving the y-axis, you can see we can paste. Yes, this is my output. I have placed it at top. Now B, that is the expression signal for carry. I am placing it below this. Next we have C. C contains input A, signal for input A. Next, D contains input B. Okay. Yes. So now I'll stop the execution and let us move back a bit. Okay. So now I'll zoom in. So how to zoom in? So here you can see you can use the scale to zoom in. This is zoom out, so I'm zooming in. So this much should be enough for us to analyze. Okay, now we know this. We will go to the output, that is our description tab. So here you observe when we have 0, 0, when we have 0, 0, sum is 0. Okay, observe here. This is 1, channel A is 1, B input is 0. So 0, sorry, 1, 0, output should be, sum should be 1. You can see over here it is 1 and carry should be 0. You can see carry is 0. When we move a little bit further, here you can see both are 1. That is, input A is also 1, input B is also 1 over here. And here you can see some value is 0 because 1, 1 generates 0, as well as carry is 1. You can see 1, 1 will generate carry 1. So in this way, we have realized an half adder. If you have any doubts, please comment in the comment section. I'll definitely help you on it. So please do subscribe to my YouTube channel, guys. So let us meet in next video.